So we talked about how to find the length of a line segment if you're given the coordinates of the endpoints or the distance. Okay, remember, whenever you see a question that says find the length of something and you're given coordinates, that's the distance formula. Okay, because length and distance mean the same thing in this case. And then, of course, we did midpoint. So now we're going to do slope. And what does the slope of a line mean? Well, it's how steep it is. It's a number that we assign to show how steep some line or line segment is. And it can go from no steepness, so like a flat horizontal surface has no slope, so 0. And then it can go all the way up to vertical, which actually has an undefined slope. We can't find the slope of a vertical line. Okay? And how do we calculate slope? Well, it's the change in the vertical distance between 2 points divided by the change in the horizontal distance. So here's 4 line segments. And we're going to find the slope of each by finding the vertical difference between the 2 points on the end and the horizontal distance and dividing them. So if you look at A, and if I went from A to B, how much would I have to move vertically to get to a level of point B? 4. And because I moved up, that's positive. So now I'm here, but I have to move horizontally to actually get to B. How much did I move horizontally? 2. And because I moved to the right, it's positive. So therefore, the change would be the vertical distance 4 divided by the horizontal distance 2. And 4 divided 2 works out to just 2. So we would say the slope of that line is 2. It doesn't matter which point you start to and count to the other point. Like we started with A and counted vertically and horizontally to B. If you did it the other way around, like if we went from B to A, how much do I move vertically? Well, I went down 4. So that's -4. And then I had to go to the left 2. So that's -2. So -4 divided -2 is still 2. Has to be the same slope. Can't be a different number. So it doesn't matter which point you start at. You get the same answer. So how about CD? let's say we're going to start at C. How much do I move vertically? 3 down, so I have to put a negative in front of it. Because I went down this time, and down on a coordinate grid is negative. How much did I move horizontally to finally get to D? 4. So my slope is the vertical change -3 divided by the horizontal change 4. And you can just leave it as a fraction. Just make sure it's reduced. I mean, I suppose you could change it to -0.75, but you don't need to. Okay, so that's it. So we would stop there. So notice that if a line climbs to the right, its slope is positive. If it falls to the right, its slope is negative. What about EF? How much do I move vertically from E to F? Do I move up or down at all? No. So what number represents I don't move at all? 0. How much do I move horizontally? 4. So I move 0 vertically, 4 horizontally. So my slope is going to be vertical change of 0 divided by a horizontal change of 4, and 0 divided by 4 is 0. Any horizontal line has a slope of 0. Always. And then finally, the vertical line. Well, let's say I want to start at G and move to H. How much do I move horizontally? How much is that? 3. Or I'm moving down -3. How much do I move horizontally? Nothing, because I'm at H. So I don't move at all horizontally. So therefore, my slope, I move down -3 divided how much I move horizontally. And what's -3 divided 0? Undefined. Can't divide by 0. So any vertical line or line segment has an undefined slope. Okay. So just as a little practice, what would the slope of this line be? Figure out, find a starting point, figure out how much you move vertically, figure out how much you move horizontally, divide them. And leave it as a fraction if you can't divide cleanly. And it doesn't matter if you start at C and move to D or start at D and move to C, it's still going to give you the same answer. And because this one falls to the right, it goes down, it's going to have a negative slope. Should we go down? 10? 2. 10, right? We went down 10. How much do we go horizontally? 5. So the slope is going to be negative 10 divided 5, which we can divide cleanly to get negative 2. That's our answer. And so for the next one, slope AB, from A to B, or from B to A, doesn't matter. It's still going to give you the same answer. So let's start at A. How much do I move vertically? 6. How much do I move horizontally? 10. So my slope is going to be the vertical change 6 divided by the horizontal change 10. Can't divide cleanly, but I can reduce that. So we just reduce it to 3/5. Yeah. What's that?
I started with speed, then I went down.
Yes, because if you did that, you would have negative 6. And then you move to the left 10, so that's negative 10. So negative 6 divided negative 10 also gives you 3/5. Yeah, that's fine. Okay. Okay. What about if you were asked to go in reverse? You were given the slope and you were asked to draw a line segment that has that slope. Okay. Any ideas how you would do it? Well, if I pick a starting point, this tells me what? I'm going to move 7 which way? Up. This tells me I'm going to move 5 right. So pick a point anywhere on the grid and then move 7 up, 5 to the right. So I'm going to pick one down here to give me room to move up and to the right. So I could start there. And then go 1, 2, 3, 4, 5, 6, 7 up to here. 1, 2, 3, 4, 5, and I end up here. So it should look like that. Perfect line segment. So that's 7/5. Another way we, like when we draw slopes on a line or when we count slopes, we often use the words rise over run. How much do you rise? Either positive or negative. How much do you run? Either positive or negative. So how would we do negative 3/8? Well, first of all, I'm going to put the negative with one of these numbers. Does it matter which one? No. Because remember, all 3 of these mean the same thing. If the negative's in the middle, you can put it up with the numerator, you can put it down with the denominator, just don't put it with both, because that means you're putting 2 negatives and that's a positive. Okay. So let's take this one. Let's say that we put the negative up to the 3. So I've got to find a point or start with a point where I can move down 3 and to the right 8. So don't start over here, because if you move down 3 to the right 8, it's going to take you right off the grid. start somewhere over here. Doesn't matter. I'll start here. So -3 means 1, 2, 3 down. +8 means 1, 2, 3, 4, 5, 6, 7, 8 right. That's my angle. So your line segment should look something like that. And that's -3/8. But again, like we did with distance and midpoint, we don't want to have to use a graph all the time because it's not very efficient. We want a formula. And there is a formula for slope. And if you think about it, when I first defined it, I said it was the vertical change divided by the horizontal change. Well, the vertical change is the difference between the y coordinates from one y coordinate to another. So I can take the second y coordinate, subtract the first. That gives me the vertical change or the rise. Then I divide that by the horizontal change, which is the difference in the two x's. So the second x minus the first x, or the first minus the second, doesn't matter which way you go. So you need 2 points on the line to use this formula. Okay? They could be anywhere on the line. They don't necessarily have to be at the end with this. With distance, they have to be at the end. And then the letter we actually use for slope is a lowercase m. Any idea what that means? Why slope m? Doesn't make sense. Unless perhaps you're French. Anything? What does to climb mean in French? Nothing? Nobody's taking French anymore? Everybody's abandoned French. All right. Well, it's monter. Okay. So let's use the formula. So we're given 2 points that are on the line. Okay, this is a line, not a line segment. Remember, they don't have to be at the ends. So call one of them x1, y1. Call the other one x2, y2. It doesn't matter which one you call which. And then apply the formula. So the slope, little m, is going to be the second y, which is minus the first y, which is right. So it changes to positive, right? Over the second x, which is minus the first x, which is. So these are actually going to become plus. So I get 1 plus 3 is 4, over 2 plus 5 is 7. Can't divide that cleanly. Leave it as a fraction, it's reduced. We're all good. That's it. This last one just gets you to think about it a little bit. It's kind of like the midpoint problem we did in the last lesson, where you're given the slope, you're given most of the information about the points, but you've got to find the missing coordinate. So what we want to do is use our formula to set it up. We know this is the slope formula. Let's plug in what we know. Do I know the slope?
Yes.
Yes, it's 2/3, so we'll place m of 2/3. Do I know the second y? No, so I'm just gonna call it y, which is minus the first y, which is 4. Over the second x, which is 6, minus the first x, which is 0. So we've got ourselves an equation. Well, I can make life a little simpler. What's an easier way to say 6 minus 0? Just plain old 6. Okay. Now what do I do? Well, this is an equation, and it's got fractions in it. How do we get rid of the fractions? Yeah, and what would we multiply both sides by? 6, the lowest common denominator. Good. So now I can do some canceling. 6 divided 3 is the same as 2/1. So 2 times 2 just gives me 4. Six divided 6 just becomes 1 and 1. Yep,
Confused with the
because it's the second one. It's the first one. Second one minus first one.
where the 3, 2/3.
How do I get to 2/3? Or how do I get this 4?
Yeah.
6 divided 3 is 2, and I still have to times 2. Right? Or think of it this way. What's 6 times 2? Divide 3. 4. Okay? So I'm left with y minus 4. How do I get y by itself? Add 4 to both sides, so my answer is 8. That's the missing y coordinate. Okay.